Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Theodore from Business Review, and I will be your host. It's our pleasure to have Akselos with us today. We'll be presenting this webinar entitled, How Can Digital Twin Technology Optimize LNG Regasification Terminals? Today's guest speakers are John Bell, who is a Senior Vice President of Sales, Ricardo Pinto, who is a Vice President of Sales, and also we have Gianmarco Tamponi, Senior Inspector, AIM Engineer and Business Developer, Bureau Veritas Italy, and Graziano Lonardi, Chief Executive Officer, Progepi SRL Gruppo Cosmi. Before we begin, I would like to welcome you to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you have received via email to join the session. In order to ask questions, you can send them in via the questions widget. Just type them into the box at the top right-hand corner of your screen and click submit. We will allocate some time at the end to address any questions or thoughts that you might have. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now, please allow me to welcome John.
Thank you, Theodore. Good day to you. In the next hour or so, we're going to take you through a project that's dear to my heart, something we started with some ambition 6-7 months ago. And the results are already out, very interesting results. In this particular case, it's an LNG regasification terminal, but this could just as easily apply to any downstream, any chemical plant, even upstream. It really is industrial assets that we're looking into and looking after. So Akselos, a very bold statement at the top of the screen, the world's most powerful simulation technology. And with such a bold statement, I felt it was necessary to let you know why we believe this to be true. Simulation technology typically has not changed very much in the last 60 years. The types of algorithms we use in legacy FEA systems really haven't changed much. And that serves us many issues. We have to make many compromises when using those legacy tools. Akselos has overcome that. You'll hear today about a model of a size that you will not have experienced before. And so we very boldly claim that we can produce models and be able to compute them, models that are typically 20 to 50 times larger than those legacy simulation technologies. We believe it's way better because we can pack so much fidelity into our models. We get greater accuracy, often 10x or more. And as I mentioned, there's no compromise on compute or on speed. In fact, many of the models we produce run in excess of 1,000 times faster. So these three areas, we believe, make us the most powerful simulation technology. But recognize this isn't easy. This was technology that took well over 10 years to develop, write new algorithms, and then turn this into a software package. So a company that had over 120 man-years of effort before it ever came to market. And it is genuinely a game changer in the marketplace. So today, yes, you'll hear from my VP of Sales for Southern Europe, who is the account director for LNG, Adriatic LNG, with Cosmi and Bureau Veritas. And myself, I'll do the opening and take you through the agenda. And my colleagues from both Progepi and from Bureau Veritas. I'd like to just take you through why this is important. It's not gone, nobody has missed out on the geopolitical events of the last 6 months, the last year, in fact. And in that, we now have market trends appearing in LNG that are both challenging, but also highly interesting. I've done my brief intro, but Ricardo will give us a bit more detail about Akselos. And then we'll look in detail at Adriatic LNG and the project background, look at some of the key results, and then open the floor for some questions from the audience. So the market dynamics that are driving change, it comes from geopolitical transitions in Eastern Europe. It comes from the drive to be greener in everything we do and reduce our dependence on carbon fuels that are pollutants. And this has driven a demand for LNG, where imports this year across Europe are 66% greater than last year, many of which are from new sources, and really is at this moment stretching the capacity within European LNG plants. What that's driving is asset integrity being critical to production more than it's ever been. You can see here that the global liquefaction capacity is really producing, but the import capacity to bring those new sources onto European soil and into the market is way below what we need. And so any gasification plant really needs to be at 100% or as close to 100% production capacity as possible, while more capacity is added all the time. And we need this because at the moment, that capacity limitation is one of the contributors to driving higher prices. And every single household across Europe is feeling this in their pocket. And so the work we're doing is to maximize the production with existing plant, and then being very targeted at what new plant we need to meet demand. So in the short term, plants are running near to their nameplate. What we mean by that is they are at capacity or near capacity. And so any shortfall in integrity, reducing that production capability, has very, very significant outcomes. And we're trying to help many companies avoid that downtime or that lack of performance. In the medium term, additional capacity is required. So just about any LNG plant is, one, maximizing, sweating the assets they already have, but already planning to increase capacity, buying new equipment, trying to deploy it as quickly as possible. And in doing so, also bringing in that digital thread that allows them to monitor 24/7 the structural performance. As we mentioned earlier, the structural performance is usually an event that we use our rear view mirror. We kind of look at things that have gone wrong and try and work out to prevent them happening again in the future. What Akselos is bringing with its speed and capacity is the ability to real-time monitor critical structural equipment. And we'll talk about that more through the presentation. In the longer term, balanced new rate gasification liquefaction infrastructure, as more supply comes online, and we try to manage those regional imbalances. And when a major supplier stops supplying, you have to move very quickly with new sources. And those new sources are available, but we have to have the facilities to import this gas, process it, and then get it to market. And this is really the challenge that we're helping companies confront. At this point, my colleague Ricardo will take over the presentation for a short while and give you a little bit more detail about the Akselos simulation platform. Ricardo.
Thank you, John. Welcome. It's good to see that we have a full house, EPC owners, asset integrity managers, reliability managers. Good. Well done. Good to see. So if we focus on the short-term issues, we have uptime, reliability, and maximizing the aging assets. That becomes the paramount of the energy security. That is applied to the whole production change, from liquefaction to gasification, both in onshore and offshore. On the rest, in the remaining webinar presentation, we will explain you how simulation of asset integrity is really important to the safety of those assets. as an owner, operator, we have two fundamental value frameworks. Usually the questions that we make, it's, are we producing safely? Are we getting the most out of our assets? Are we achieving operational excellence? From a metrics perspective, the KPIs that goes with are safety, utilization, availability, and profitability. So there are a number of levels that operations can influence these key metrics. Like to positively impact that levels, you need definitely intelligence at speed of operation. There is no point in discovering a failure that you could have prevented an unplanned downtime after the fact. So what I want to say is to managing those levels require to look at the process side, but as well at the assets themselves. And of course, it's linked to asset integrity. So that is where we play. So structural digital twin is what we are providing to our customers. Our technology allows you to move from typically a run to failure maintenance approach that you have in some of your assets to a predictive maintenance based philosophy. So we are talking here about the 24/7 surveillance of your critical assets across your entire fleet. So structural integrity, yeah, it's really important to have the asset management control of your assets. What I meant to say with this, it's like you could really definitely improve your P&L if you could reduce dramatically the hotspots, so improve your inspection plan, as we are going to show on the next slides, unlock the fit for service, the FFS constraints, and as well having a continuous fit for service assessment available to your assets. So let me give you as well, that is important for you to follow this presentation, just a background about what is a digital twin. So many of you already heard about this word. So the most common one is the virtual digital twin, is when you have a 3D visualization of your unit. You have companies like Autodesk or Visiones that provide such solutions. You have a process digital twin that is a physics or a chemical map out of your process that you could apply what-if scenarios to understand their effects. And you have a structural digital twin, that it's what we fit and where we belong to this digital world. So our structural digital twin, we provide a fully parametric physics-based model. And most important, we are bringing this from the design phase to operations. So having this in almost real time, and when I say real time, per cycle of our assets. And that is really powerful. So we deliver our solutions and our models for the entire fleet, and we focus in the most critical assets. So we have already deployed in assets as cokers, pumps, pressure vessels, SMR, reactors, turbine. We recently deployed a site-wide project at Shell Qatar. And today we are going to focus on the most critical asset on the LNG platform, that could be ORV. So let me introduce our colleague and partner from Cosmi, Mr. Graziano. Graziano, moving to you.
Yeah, thank you, John. Thank you, Ricardo. Let me introduce my company in a few words. Established in 1974 as a construction company, Cosme specialized throughout the years in various energy sectors, focusing in particular in the oil and gas. Today, it is an integral part of a group of operating companies providing the management and execution of national and international projects in various fields: brownfield, supply chain, logistics, and construction. Cosmic activities include all stages of industrial construction for the offshore and onshore sector, as well as for oil and gas and chemical companies and the whole industrial field in general. ProJP is an integral part of Gruppo Cosmi. Started its business in 1999 as supplier of engineering service for the chemical, petrochemical, and environmental sector, and its solid experience allowed the company and the group as well to range from the design of oil and gas plants to offshore and maintenance engineering, providing a complete and professional service both in Italy and abroad. ProJP is a supplier of cutting-edge tailored solution of project management, consulting and industrial engineering services, mainly for the oil and gas, petrochemical, power, and offshore design sector. Other company commitment in the last year, the engineering team focused in identifying, developing, and deploying advanced and integrated digital solutions. In 2020, Akselos and Gruppo Cosmi undersigned a partnership agreement to bring into the market the Cosmi approach, namely Asset Integrity 4.0, for the optimization to asset integrity and extension of residual life of onshore and offshore structures. In 2022, Adriatic LNG has requested to Cosmi to build a digital twin to support the assessment of a 12-year-old open rack vaporizer that is a part of the plant of LNG. Adriatic LNG is the biggest regasification terminal in Italy, with a production of 9 million natural gas per year. 9 billion. As a strategic asset, it is really important to maintain high production levels by avoiding unplanned shutdowns. And Cosmi, as prime contractor for maintenance activities for Adriatic LNG terminal, has developed a deep understanding of the LNG regasification process over the years. One of the most critical equipment is the open rack vaporizer, the equipment where LNG vaporization takes place. 4 LNG vaporizers using heat naturally contained in seawater are installed on LNG terminal. The open rack vaporizer utilizes seawater to vaporize the LNG. The OLV are made up of multiple sections of vertical panels of aluminum finite tubes, which are manifolded to LNG heater at the bottom and to gas heaters at the top of the RV. The LNG flows through the tubes from the bottom up, while seawater flows down over the outside finite surface of the tubes, collecting in the basin at the base of the panel, and from there, the seawater flows by gravity to the sea. Routine inspections of the ORV units show that the deformation of some pipes on the outer fringes of the Unit 3 occurred, and we wanted to investigate the impact of the observed bending on the stress level of the tubes. Thus, our challenge was to understand the mechanism of cycle wear and tear and how they interact with asset operation. For this reason, we investigated potential and creation of cracks. Issues become problems that lead to unplanned shutdowns, increased fatigue accumulation, which can cause shortening asset life, and the final, residual plastic deformation.
Graziano, before we move on, could you let the audience know, what was it about this asset where you believed Akselos to be your first choice technology to help you solve the issues the ORV faced?
Well, John, thank you for your question. We had the areas of deformation, and we needed to know how the entire ORV would react to any significant areas of stress. Local models would have taken too long to build and would not have provided the holistic view we were looking for.
Okay, could you please describe the two phases of implementation?
Yes, of course. Yes, of course. In the next few minutes, I'm going to show you the first phase implementation plan already completed and second phase still ongoing.
Okay, could you give a brief description of how you went about building the model?
Yeah, basically, we went through three main steps. The first step, starting from the CAD model, we set the boundary conditions. Second, we did a merge convergence study. And third, the temperature distribution that we provide in the tubes. At the end, we also performed the model evaluation based on ASME standards, validated by Bureau Veritas.
Okay, so this is a lot of tubes on 5 racks there. You're not concerned in a single model that this might just be too large to even compute?
Yeah, normally we would be, but we built large models in Akselos before, and so we were confident the software could manage the challenge. We wanted to see not only the impact on the tubes with known bending moments, but also the impact this may be having on other tubes in the array.
So what data did you capture?
We have captured all boundary condition and current condition data from historical inspections. This may seem straightforward, but these are huge units, and capturing everything in one single model had until now been considered impossible.
So I guess the $50 million question is, how large was this model?
It was very large. The model exceeded over 500 million degrees of freedom, but it was essential that we did this in a single model to accurately observe the impact across all arrays.
Okay, and I believe you did a mesh convergence study. Why was that necessary?
Yeah, it was essential that we did a mesh convergence study to ensure model accuracy and to get the right fidelity in the model for the type of analysis we were about to run. For building model, we use the element type of HEX20 quadratic order with 1.5 million degrees of freedom per tube, for the reason that quadratic X gave the best convergence, but this means the model was going to be huge. We were very surprised that Akselos software could cope with such huge FIA model. We applied the temperature distribution and the operating pressure within the model and ran an intensive fitness for service assessment. We established the curvature of the tube was almost entirely due to temperature ranges. The tube were subject during startup and shutdown cycle. We also established a stress ranking for every tube in order to focus future inspection efforts on those tubes most prone to potential cracking, effectively creating a stress hotspot map across the entire array.
So what analyses were you performing?
We performed a fitness for service level 3 assessment to API 579.
Now moving on to the final results, what exactly were you focused on?
We focused on the entire unit, 68 tubes in 5 arrays. So we can say that we passed the assessment, but discovered a wide variance in the stresses at the tops and the bottoms of tubes, and that some tubes were under greater stress than others. The model has now enabled us to rank the tubes based on fatigue life status and update our RBI accordingly. The assessment has been performed for every tube in the current RV module. For the tube with bending, both straight tube and bending tube will be performed for evaluating the effect of bending to check, and the diagram that you have in the slide show you this effect. The figure shows the maximum plastic equivalent at the checking load case for 68 tubes and 5 panels. In this slide,
here are some of the results,
yeah. In this slide, you can see the distribution of stress for every tube in one array on the bottom weld. And in the next one, you can see the same result. And in the last, you have the distribution of the stress result on the foam mesa stress investigation for the top weld. And in this slide, you have the value sorted.
So what's next, Graziano?
Next, we'll be deploying on all 4 of our OLV units and use Akselos for near real-time monitoring of the entire structural integrity, a full-time and near real-time fitness of service on demand, with the help of our friends of Bureau Veritas Nexta.
Well, thanks, Graziano. Fascinating. I think at 500 million degrees of freedom, I think you've beaten our previous record. And I'm glad to have been part of this project to see that. Next, we have Marco, who offered further analyses and validation of the fitness for service studies. Marco.
Thank you, John. Welcome to everyone again. So, Bureau Veritas Nexta is a Bureau Veritas group company. BV Nexta supports clients managing the risk along the entire life cycle of facilities, industrial or civil assets and infrastructure by developing consulting and engineering services oriented towards strategic planning and sustainability. BV Nexta purpose is to prevent risk, consolidate and evolve the business of our clients by enhancing their contribution to the community and environment. Thanks to multidisciplinary technical expertise and to a streamlined and dynamic approach, BV Nexta provides clients with innovative instruments and solutions so that they can achieve strategic compliance and performance. Also, BV Nexta express all the know-how and history of an important international group like as BV Italy in its consultancy services, effectively fulfilling the present and future demands of a constantly evolving market. So, main consulting services are asset integrity consulting, technical advisory, testing and inspection, and in particular, fitness for service and station life. The main services for fitness for service station life are, for instance, stress analysis or strain analysis, residual life calculation, root cause analysis, failure analysis, and all type level of fitness for service assessment according to the standard. But what is for fitness for service analysis? According to API 579, fitness for service assessment are quantitative engineering evaluation that are performed to demonstrate the structural integrity of an in-service component that may contain a flaw or a specific damage. In particular, level 3 assessment procedures are intended to provide the most detailed evaluation. In a level 3 assessment, the most detailed inspection and component information is typically required, and their recommended analysis is based on a numerical technique such as the finite element method. The main objective of unfitness for sales assessment are to demonstrate through detailed studies further reliability of an equipment even beyond its design life, and also to demonstrate further reliability of an equipment even when design conditions are changed, or in presence of a defect, or in presence of a specific damage mechanism, for instance, plastic deformation. The main step of this kind of analysis are starting from design data analysis, maintenance and operation data analysis, also the study of inspection plan and the history of the inspection. Then there is the fitness for sales assessment, and as a main result is to give a remediation in service monitoring recommendation. So, which type of fitness for service assessment we have performed for open rack vaporizer? As showed before, the main fitness for service assessment performed are two types. First one is a structural integrity analysis performed according to ASME code. And second one is fitness for service assessment considering cyclic type dependent structure analysis. From a structural integrative fitness for service analysis, the main outcome is that the current bending status of ORV is allowable according to ASME requirement. And according to this fitness for service analysis, the ORV can be put in service even the rather present of very large deformation of inner pipe up to 95 millimeters. The second type of fitness for service assessment is type dependent. The main objective of this kind of fitness for service is to evaluate the residual life of ORV, considering an cycling time-dependent structural analysis. This analysis has been performed in order to estimate the number of cycles of active crack nucleation due to cyclic bending deformation generated by startup and shutdown cycles. Starting from a digital twin model, the fitness for service assessment was able to predict the nucleation of a technical crack, which is detectable by conventional non-destructive technique. So, as told before, Akselos digital twin of ORV gives a detailed map of elastic plastic behavior of the whole ORV. A very complex model has been developed considering static supports, the two manifolds, the 5 panels of finned pipes, and 68 finned pipes of each panel. So, starting from digital twin, the zone of maximum plastic cyclic strain have been defined, and in this zone, the fitness for service model has been implemented, and the main result applying this second type of fitness for service model is to estimate the number cycle of fatigue crack nucleation. So, from cycle time dependent structural analysis, the main result are as follow. Cycle type dependent structural analysis have been performed in order to estimate the number cycle of fatigue nucleation due to plastic cyclic loading. The number of cycles to nucleate a fatigue crack at the most cyclic strained zone has been evaluated. So, considering the actual warm-up cool-down cycle of RB, the fitness for service assessment for cycling load revealed that fatigue crack nucleation may occur during service life of the equipment. Thank you, John.
Okay, thank you, Graziano, thank you, Gianmarco, for all your really pretty good and amazing job that we have been done here for our customer, Adriatic LNG. So I will move just with a quick summary of this presentation before we start with the Q&A. 4 main takeaways that I would like to discuss with you. So using a structural digital twin, as you could see, could reduce drastically the number of the hotspots, and as well, the customer could have more time to focus where the really issues are. Having such a level of high confidence model definitely could extend the life of this asset. And as a third one, we are the only one providers that we could give a continuous fit for assessment in almost real time, meaning per cycle. Most of you already know the costs that needs to be applied and the logistics to do such analysis. So a more effective maintenance and inspection plan reduce dramatically the cost of OPEX. So, and the last one single source, so connected with operational conditions. We can have historical data storing as the OZ soft PI, and as well reporting from BCS. So all of these 4 main takeaways applicable to all critical LNG processing equipment. So John, if you want to add some content here, otherwise we can move to the Q&A. Okay, so before moving to Theodore, I wanted just to highlight, this is some of our references, customers that we have on the bottom, from LNG, downstream, greenfield, brownfield, renewables, across over the world. So Theodore, moving to you for the Q&A questions. Thank you.
Thank you, Ricardo. Thank you for the great presentation to attendees. Now we have a few minutes to address some of the questions you have. It's still possible for you to submit your question. Please use the question widget at the top right-hand corner of your screen and click submit. But yeah, let's begin with the first few questions we have. Does your technology apply to the process vessels only, or do you also model the host and structure of steel?
John, should you take this one? Okay, I can take it. Yes, we already complete work for FPSO hulls and an LFNG as well. Also offshore jacket structures for wind and oil and gas and many, many, many more.
Thank you, Ricardo. Moving on to the next question. Is there a reason you didn't use existing FEI simulation engines or software?
Yeah, I think Gianmarco, this one's for you.
Yeah.
Well, I can answer this if you will. You know, the choice is there to use legacy FEA simulation engines, of course. The particular demand on this is that we had one holistic model. And that meant that whether it's going to be 20 million degrees of freedom or 50 million, as it turned out, it's 500 million degrees of freedom. It's our belief that there is no other product on the planet that can handle a model of that size and you get reasonable response from just standard compute. This did not need a supercomputer to compute the results. It was done on a regular server. So I think you know, the ability to get an holistic model that would link to data, mainly inspection data, and then some of the load cases from collecting the temperature data of the tubes and the pressure from within the tubes. So this was a multi-physics model of great size. And yeah, having worked with legacy FEA solutions, we just didn't feel they had the power to be able to handle this.
Thank you, John. Next question we have from the audience today. How long does it take to build a model of the ORV and to run it?
Yeah, I
perhaps
can
Graziano.
answer. To complete. Yeah. Thank you. Thank you for the question. To complete the heuristic build of the model took about 12 weeks. And to run it, the complete model of 500 million degree of freedom took about 4 hours computing. That is a very record, I think. We can now have a fitness for service level 3 assessment per cycle.
Excellent.
Thank you, Graziano. I can see we have a couple more questions. Was anything else modeled?
Yeah, I'll pick this one up. I mean, this is phase 1 of 4 ORV units that will eventually provide near real-time continuous fitness for service and condition monitoring. So if you think about this in legacy terms, this would take many, many months to do a fairly small submodel. We're doing entire ORV frames and giving sub-second response per tube. Calculating all of them, yes, took 4 hours. But, you know, we did that on a linear compute. We have the facility to parallel compute this so that we can get much, much faster results as we go to the real-time monitoring. And that'll be the next phase of the project.
Thank you, John. Next question. What are the plans for future expansion?
I can take this one. So yeah, the plans that we have, we already start to deploy on the other remain 3 ORVs. We are moving forward to a site-wide deployment. We start as well to prioritize the assets for the deployment, such as recondenser, 2 brines, and lift cranes. Thank you.
Thank you, Ricardo. I think we've covered all the questions we have received from the audience today, which leaves me to thank all the presenters for what was a great presentation and to Akselos for sponsoring this session. To attendees, you'll receive an email shortly telling you how you can access the on-demand version of this webinar, or you can do that through our website, which is www.pmi-live.com/events. We look forward to sharing further webinars with you, so please do keep an eye out on the website I just mentioned. Thank you once again, and I hope you all have a great day. Thank you.
Thank you. Bye.
Thank you. Bye. Thank you.